Everyone, Krishna here, and I hope you all are doing great. It's been a long time since I uploaded a video on this channel. In today's video, we'll cover another popular system design entry question, that is design top K trending videos. Although this trending videos is an example, but similar concepts may apply to many similar interview questions. For example, the interview might ask you to design top K trending songs or any other trending content platform. Okay, the underlying approach remains almost the same with only few variations depending on the use cases. Okay, so without wasting any more time, let's start listing the functional requirements. Good set of functional requirements would be like the first thing is obviously every time user watches a video, the view should be counted, right? That is something what bare minimum we expect from everyone. The next is like we should return top K trending videos, right? So now here we can ask like do we require all time videos or we require multiple time frame windows support, like last 1 hours trending videos, last 24 hours, 7 days, 30 days, even yearly basis. So those things, a couple of things we should ask, and then we have to note them down. What are all functional requirements that we are supporting, and how we will add them in our architecture. Okay, so let's note them down. Like I'll just quickly note all of them, whatever I discussed. Okay, so I simply noted down those functional requirements. So every time user watches a video, the view should be counted. That is fine. Then we have to get trending videos of all time. Then we should support multiple time windows, like whatever trending videos in last hour we saw, those needs to be returned. 1 day time frame, weekly trending videos, even monthly or even yearly also we can add it based on the requirements. Okay. Now here, what does this last 1 hour mean, right? Like that is something we have to get clarity about. For top K trending videos, the requirement is going to be straightforward. So for now, like it's 8:15 for me, right? 8:15 is something what going on for me. So last 1 hour means like, are we supporting a time frame like from 7:15 to 8:15, whatever trending videos that we saw, are we have to return those trending videos, or last 1 hour means like it the time frame is like between 7 to 8, whatever trending videos that we got it in between that time frame, that is something what we are supporting. So that clarity is something what we have to get it right over here, because for system like these trending videos, no one really cares like for each minute basis whatever trending videos that we got it, that is something what we have to return to the user, right? Because these systems are seriously a bit heavy, as we may get 50 billion views on daily basis, and for a minute basis whatever trending videos that are there, if we are supposed to return, obviously it is really hectic system that we are designing. So there could be systems which require minimal efforts. There we can completely focus on that time frame window. It's like a sliding window time frame, right? Like between each minute, whatever training videos that we are getting it, we are simply returning it. Like for daily basis, like you can even imagine now, like per minute basis, like whatever daily videos that we have got, that is something what we are trying to return. So obviously this type of system does not require sliding window approach. Per minute basis, whatever the videos that we got it, training videos, that is something what we are trying to return it to the user. So we will focus on this tumbling time frame window. Okay, we generally call it. So last 1 hour means like whatever last 1 hour that has been passed in that time frame, whatever training videos that we got it, those are something what we are returning it. 1 day means like it is again same, whatever training videos that we got it previous day. So we are not again considering the minute level basis time frame. So those videos are something what we are returning it back to the user. Okay, so same goes with weekly and monthly. So here the time window that we are supporting is obviously going to be tumbling time frame window. Okay, these are a couple of functional requirements. Again, like there could be many more functional requirements that we can get it, but I think these are more than enough to design and build a system for this top K training videos. Okay. All right, so now let's focus on non-functional requirements. So the non-functional requirements describe how system should behave rather than what it should do, right? The most important ones to mention in the interviews are like first thing is obviously we have to consider about the cap theorem. So in cap theorem, obviously here partition tolerance is a must, right, for designing this type of systems. So between consistency and availability, we have to go for availability right over here, because user should be able to retrieve training videos even if some server fails. Obviously availability is something what matters the most in these type of cases. So yes, system should be highly available. The latency that we are considering right over here, it should be below 50 milliseconds, because we are just simply returning training videos that has been pre calculated in our systems, and we just have to return back it to the user. Okay, we can here consider that for these type of systems, approximation really works very best, because no one really cares exactly whatever videos that we return to them, are they accurately calculated, or the result that we got is actually precise. So here we will consider both the things, like we will try to see how precisely results whatever we are getting it, we are returning back to the user, and then we will discuss about the approximation as well. For approximation, we have to use here count min sketch. That is another algorithm that we will discuss in this particular video. Okay, so yes, let me note down all the non-functional requirements for it. Okay, so yes, as I discussed, like availability is something what matters the most for these type of systems. Then low latency, we'll try to get videos in 50 milliseconds, then the result is going to be precise. That is the approach that we will discuss first, and then we'll talk about the approximation as well. Okay. Now, if we discuss about the scale of the system, so we may get some numbers like 50 billion views is something what we are getting it on daily basis per day. So these many views we are getting it, right? Obviously, we try to get per second basis, like how many views we are getting it. So it is like 50 into 10 power 9 divided by up, see, like we are trying to get it per second basis, right? So we can simply divide it by 10 to the power 5. No need to remember like the exact number that we get it. It is around like 86400. We can simply divide it with 10 to the power of 5 to get the approximation numbers, because no one knows like these whatever numbers we are getting it, they are also real or not. Okay. So here the per second basis, if we see, it is like 500k views we are getting it per second. So this is the scale of system. These many views we have to handle it, and we have to get trending videos out of them. Okay. Now, during peak time, obviously, if we multiply it with 2, we may get 1 to 2 million views as well per second. So that is the scale of system that we have to handle it. Okay. So yeah, these are a couple of things that we have noted down. Now, what are core entities, right? So let me note it down. Core. The first is like obviously video metadata, so many things that we get it, right? So user, okay, that is also another entity that, let me note it down. Time frame is also there. Okay. What else? Like whatever views that we are getting it is kind of an event. So view event is also something I'll note it down. Okay. So yes, these are a couple of core entities that we have it. We are using here simple REST APIs to get all the training videos, because we don't have to really depend on any other communication mechanism, because this is the request response use case, and obviously REST works perfectly fine in this particular case. So yeah, let's note that REST endpoint as well. So the endpoint is basically simple. It's an get request, right? So it is like slash API slash v1 slash trending videos, fine. And then here we can provide k, the window, the number of top results the client really wants. It could be like 10 top k trending videos. That means like top 10 trending videos, 100, and we limit this number as well, right? Like we may provide at max 1000 videos, even if client try to get more and more, but 1000 is the max limit for this k. So here, if they wanted to get top trending 50 videos, and then the time frame is also we have to note it down. So it is like and is something what we have to use. So the time frame, uh, okay, so it could be like 1 hour or 1 day, something like that. They can provide it. Okay, even the custom time frames also they can provide, and we have to retrieve that data, and we have to return it back to the user. So yes, that is the simple endpoint that we have to consider right over here for this particular system. Now let's start designing the architecture for this particular system. Okay. So we will assume that users from multiple regions are watching the videos, and every video views request goes in our backend. So these view requests first reach to a load balancer. So let's have a load balancer right over here. Okay, and its responsibility is to distribute the incoming traffic evenly across the servers. Okay, so let us assume that our system receives around 500k views per second, right? A single server obviously cannot handle this amount of traffic, so we'll need to scale horizontally by adding more and more servers right over here. So all these views that we are getting it from the load balancer lands upon servers. So these servers, let us say I'll not fill anything inside right over here. So obviously these servers needs to be scaled horizontally, as in a single server cannot handle 500k requests at the same point in time. So typically, if any particular server is handling 5k requests, that is something what we are assuming it, because this particular server's job is far more than just simply collecting the views. Okay, it has to further create events. Then it has to, obviously, like we have to validate the users and all so many things these servers typically do. So we will assume that 5k requests are something what a particular server can handle at same point in, per second basis. Okay, so 500k requests we are getting it, and then 5k requests. That means like we need to require 100 such servers. Okay, to handle all those views that we are getting it from different regions. So 100 such servers is something what we are having right over here. That is the amount that we require. So each particular servers handling 5 requests. Okay, so that is the nice assumption that we can have right over here going ahead. Now the next thing is like obviously these views needs to be processed. They have to be considered in a form of events. Okay, so for that, like the system that we look around is like obviously Kafka. In Kafka we can easily create these events, and we can work upon those events so smoothly, like no other system can give the best result that the way Kafka generally gives us. So obviously we have to generate the events. Okay, whatever views that we are getting it from the users, so we'll try to create it in a form of events, and we will put it into the Kafka. And further we will discuss like from the Kafka how we can aggregate those views and we'll store it into the database, and then how users can request for those views. Like that flow is something what we will keep on discussing going ahead. Okay, let me just add Kafka. So these whatever views that we are getting it, these are the producers, right? Like as in since we are dealing with the Kafka, so these servers are the producers who are producing the views, and in the Kafka we are storing all those in a form of events. Then there will be a consumer who consume those views. Okay, and those consumers job is like they have to aggregate the results or directly simply put it into the database. So those trade-off we will discuss. So first, let's add Kafka right over here. So I just added Kafka. So let's talk about what these application servers actually do. Okay, so these application servers act as Kafka producers. Their responsibility is to receive incoming view requests and publish them as a event to Kafka, right? So we'll create Kafka topic called video view. Okay, so this is the topic which basically collect all the events. Every time user watches a video, the application server create an event containing information like okay, this is the event that we are creating, and it holds like video ID. Okay, my ID like 1 2 3 4, then user ID something like that. Okay, again XYZ something like that. Okay, and some other metadata like timestamp, country, device type, all these information, something whatever necessary information that we require, those things we will add it inside here, and that is something what we have to put it into the Kafka inside this video view topic. Okay, so now if we are receiving around like 500k views, right, per second, a single Kafka broker cannot handle this traffic, right? So we have to create multiple Kafka brokers and partition the topic across them. So that's the goal. Okay, so this video view will get partitioned across these Kafka brokers. So let us suppose 10 Kafka brokers are something what we have created right over here, and there will be 200 partitions. Okay, just assuming these numbers. Okay, we'll talk about them as well going ahead. So now the next question is like, how does producer know in which particular partition the event needs to be sent, right? Like, because 200 such partitions are there across these Kafka brokers, and I said like we will be having 10 such brokers. Okay, the number could be anything. Okay, but just assuming it for now. So each particular Kafka broker will be having 20 partitions. Okay, because it gets evenly distributed whatever partitions that we have created. Now in which particular partition this particular video needs to be sent as an event from this producer, that is the question, right? So the idea is pretty much simple. Whatever video ID that we are having it, right, because it is basically unique. So what we can do is we will create a hash of this particular video ID. Okay, so whatever video ID that we have, we create a hash. So let us say the number is something what we got is like, this is the number that we got it, and obviously like let us say 1000 is something what the number that we got it. So what we can do is like 200 partitions we have, right, and we have to ensure like in which particular partition this event needs to be sent. So we simply mod it with 200. This gives us obviously like 5 is the number that we are getting it. That means this particular event needs to be sent to the fifth partition. Okay, so wherever the partition 5 is residing inside this Kafka brokers, there this particular video event basically get sent. Okay, that's how things works right over here. So around 200 partitions, obviously whatever video ID that we are having, we will hash it, and we'll mod it with 200, and whatever number that we are getting it inside that particular partition, we will send these events. Okay, now, one important optimization is how producers send the events to the Kafka, right? So, since we are getting it 500k views per second, and if we try to make that many network calls over the Kafka, obviously it creates unnecessary network overhead and reducing the throughput, right? The further optimization that we have to talk about is like, are we seriously going to make 500k requests to just send these events into the Kafka? So the answer is obviously not, right? Like we have to think about optimization, and Kafka does really great work right over here. So in Kafka, there is something called bash.size. Okay, so if let's suppose its size is like 64 kilobytes, so in one particular batch, 64 KB size of data is something what we can easily send from these producers. Okay, so that is what it basically try to say. So if this particular events that we are having, if the size is basically around 200 bytes, okay, we can assume that. So obviously 65 k or 65,000 divided by 200, this basically gives us generally around 300 plus or even 320 something what that number is something what we are getting it. So 320 events we are sending it. Okay, these many events we can easily send or the network per network call. Okay, so obviously if we are sending 320 events per yeah, per network call, that means like if one particular service has 5k, sorry, 5k requests. So we are not making 5k network calls. Instead, we are sending 320 events per second. Like let me just assume 300. So obviously it is going to be uh, I mean around 15 network calls or something what we are making it generally, correct? So that is something what we are dealing. So instead of making 5k network calls to the Kafka, we are sending these events in a form of batches, and we are simply reducing these mini network calls to just around 50 or 20, even like max to max 30, 50. That is the number that we are getting it. So we just simply reduce those mini network calls to this one, okay, just because we are having this batch dot size concept available in the Kafka. Okay, so that is the optimization that we can make it for the network calls. So we understood like in which particular partition the event are basically going, how we are optimizing to ensure that these producers are sending events in form of batches to these Kafka brokers or these clusters wherever the request basically has to land, the event that has to land. Now, since these Kafka are collecting all the events, now the further thing is like we have to consume these events, we have to work upon aggregating those events, and then we have to store it into the DB, and from there we have to send it back to the users who are making request to get the trending videos. Okay, that is the flow, right? So simple thing is like now from the Kafka we have consumers who are consuming the views, right? So let's suppose we have again some servers that are there. So these are the servers. Let me fill empty. So these are the consumers. Okay, so they're consuming these views from the Kafka. Now the consumer job is like simply they pull the events from this video view topic, and again here a single server won't work, like we have to be horizontally scaled these servers as well who are aggregating the views. The idea is pretty much simple. They pull all the events, so one consumer can handle multiple partitions, so they basically collect all the events that are available in that partition. We do not require like 5k requests a particular consumer can handle. These consumers are just simply pulling those events, right? So and their job is like just aggregate them and put it into the database. So obviously like a single consumer can handle 25k requests as well at the same point in time, because these producers are doing so many jobs, like they are creating the batches, authenticating the users, and also like it requires some extra efforts right over here. So we just set like 5k requests, but here it can handle easily 25k requests as well, so depending on the events that we are collecting. Okay, so now these consumers, their job is like just collect the events from the Kafka. Okay, from this Kafka these consumers are collecting, so all the Kafka brokers that we are having, right? So these consumers are collecting them and then aggregating the views. Okay, the thing is like we are not simply sending the views directly to the DB, because again these 500k requests that it is handling, these consumers handling per second, those events we don't want to directly send into the DB, and we don't want to overload the DB as well. So what we can do is like we will simply, since our requirement is like hourly basis. Okay, so per hour, like how many views that a particular video that we got it, so those things we can aggregate directly into these consumers. Okay, so what we can do is we call it as view consumer, something like that. Okay, who are consuming the views, and then they will aggregate the views. So, and hourly basis we will aggregate them, and then we will flush it into the DB. So that's the job that these view consumers are doing right over here. What we can do is like in memory, like a hash map or something like that, we can hold, and whatever different views we are getting it for different video IDs, that we can store it in them, and we can keep on incrementing whatever polls that we got it. That's the simple job these view consumers has to do. And once hourly basis, whatever the views that we got it for that those particular different views, they simple these consumers job is like they have to flush it into the DB. Okay, so what I'll do is I'll just simply move this block diagram a bit down. Okay. Okay, now so the idea is whatever aggregated data that we are getting it in the from this view consumers, we'll simply flush it into the DB. Okay, so there will be a database in which we are just appending these views. Okay, since we are aggregating the views, so how we can put the data inside this DB is like the video ID. Okay, it will be there. So simple. Here I'll be using SQLDB. We're not going to NoSQLs. Okay, as in data that we are getting it, we are simply appending it inside here, right? So no need to think out of the box for going for time scale DB and all. Simple. We are getting the data. We are just simply appending it into the database. So here the video ID is the first column. Then there is obviously view count. Okay, let it be like 1,000 views. We got it in an hour. Timestamp is also there. So per hourly basis, we are just flushing the data into the DB. Okay, so it could be like 11 a.m. Whatever the timestamp that we are holding it in that timestamp. Okay, so those are a couple of things, some other metadata and all. We are just holding it into the database. So now, what do you think? Like, do we really need to just get the data continuously from DB for one day basis? Like, we can simply make a SQL query, select from these particular tables, and then we aggregate the data for that particular views for daily basis, and then we send it back to the user. So it is obviously again we are making a lot many requests to the database. So to avoid that, what we can do is like we can maintain separate database. I mean tables. So this is like for per hour basis we are holding this data. So again like per daily basis, like we can simply query from these tables, like whatever the day range that we are having, that we can consider, and we can flush the data inside that daily basis table. For weekly also we will be having another table, and for monthly also we will be having separate tables. That way what happens is like we will not query to this particular single database for daily basis. Once the data is flushed into the DB, whatever top k results that we are getting it, we can simply return it back to the users. Okay, so the idea is pretty much straightforward. Like instead of putting all the data in hourly basis, we will separate out all different tables for daily basis, weekly, and monthly. And since daily, only on daily basis, this data is basically getting updated. For weekly, I mean, whatever the daily data that we are getting it, we will aggregate for the last 7 days data, and we will put it into the weekly. Same goes for monthly, like 4 months, 4 weeks data, whatever we're getting it, we will add it into the monthly basis tables. Okay, and that way we can simply get it those data, and we can simply return it back to the users. So it is like per hourly basis, like whatever the video ID that we are having it, the views that we got it at 11. Then like again the same video ID like we have, right? So for that particular video ID, whatever views that we got it, like let us suppose 2000 views that we got it for the timestamp, like 12 like that. Okay, so this is how we are simply putting this data inside the database. Okay, so let us suppose from here the clients will started making requests to get the, okay, get this request. Okay, they are started making the request, so obviously we will be requiring a server from which the request basically goes, and they start making the request and basically get the data from the database. So the first thing is like obviously here API gateway, load balancing, something like that we can consider. Okay, so everything like authentication, authorization, rate limiting, all those things will happen inside here. Then this is API gateway communicates with trending videos server, so obviously they will be horizontally scaled. Again, like there will be multiple instances available, like multiple servers will be available, and this we can call it as trending videos, trending video, something like that. Okay, so these are the servers that we are having upon which the requests are basically getting landed. From here, now the idea is like we started making requests to the database, okay, to get top k training videos based on the indexing. Like we can simply trace out the data and we can return it back to the user. But obviously, like if we keep on making requests to the database, it will be problematic, because DB reading constantly from directly from the database will obviously make these things quite heavier. Whatever low latency that we are expecting, the database may not give us back that level of low latency. So we have to ensure that here between this database and here we will be having something called a cache. Okay, Redis cache or something like that we can use. Okay, so in the cache what we can do is we can simply flush the top trending videos, records, everything inside this cache. Okay, so let me color it something else. Okay, so in this cache the data is basically getting stored. So results that we are getting it from the DB, we cannot simply get it directly from this one, right? So we have to constantly hold the data every hourly basis, and we have to flush it into the cache. So for that, like we can run some cron jobs, and their job is like they will keep on collecting the data from the DB every 1 hour. Like they will make requests from the database, and whatever results that we are getting it, we will put it into the cache. That's the idea. Now let's talk about again back from here. So obviously, whatever the views that we are collecting, and we have to put it into the database, the precise result that we are trying to get it to the user, right? That will hamper right over here. So what we have to do is instead of having the view consumers single instance, like we can have replications, but obviously more and more servers will be added here. Cost is something what we have to deal with that. So any particular views that we are collecting in one particular consumer, that is something what getting replicated in another server. So if one instance goes down, another instance may take the place, and it starts collecting those views from there. And again, even if one server goes down and we are not having replications, right? So the Kafka is always source of truth, right? So these Kafka basically hold the events for longer run, as long as we want to hold them. So the views that we got it lost, again we can get it back from there. But since the precise result is something what we are looking out, we have to either add more and more servers, or the idea is another thing is like we can simply flush data into S3. So what we can do is like so for results that we got it every 2 minutes or 5 minutes, we can simply keep on adding it aggregated data into the S3. So even if server goes down after a certain point in time, once it comes back, at least like we have some results that got pre-computed, and whatever the results that we have to catch up, we will simply catch it up from there. So at least some sort of improvement will be there with this particular thing. Okay, so we will put the data results into the S3 if needed, to make sure that whatever the views that we aggregated, that is something what we are not losing it, and we are not again calculating every single thing. Now in the DB, like we cannot simply write 500k queries in single, I mean it is not 500k queries, but simply like whatever aggregated results that we are doing it and writing it into the database, single DB instance may not hold it. So obviously some sharding and also something we have to do right over here based on video IDs or something like that. And then we can create multiple sharded DBs, and from there we have to collect the top key results, and among those top key results we have to ensure whatever top results that we are getting it out of them, that is something what we have to put it into the cache, and from there we can return back the results. Okay, so those are a couple of things that we can do right over here. Now what if the cron jobs is something what we failed, like from the cache directly we cannot get it the data from the DB, right? So it is obvious that if crons are something got failed, so we have to ensure that whatever data result, that previous result that we are holding it in the cache, that is holding for a longer duration. The time to live TTL is something what we have, right? So it may, like, we can extend it for 30 days, like, because that is the highest thing that we are holding, so that previous results at least, like, we are returning back instead of returning nothing. So that is something we can take care of right over here. So since the availability is something what matters the most, so we have to deal with these things at any point in time. So far we discussed how to get exact counts, right? Now let's look at how to get approximate counts using count sketch algorithm. In count sketch algorithm, this algorithm is generally a probabilistic data structure which estimates the frequency of items while using very little memory. Okay, so instead of storing every unique video ID, it maintains two-dimensional array of counters, right? So these arrays has the rows which we call it as depth, and there are these columns which we call it as width, and each row uses different hash functions. So these are different hash functions that we are having right over here. Okay, when a particular video event arrives at the consumer side, okay, from the Kafka, what we generally do is we pass that video ID to all these hash functions, and we calculate the hash value using these hash algorithms, and whatever count values we are getting it, we will increment in those particular indexes. Let us suppose a particular video ID is something 1 2 3 4, and we use the first algorithm SHA256 to get the hash value, and the answer is like in this particular index, like here it appears as 1, and again here it appears as 1. So whatever previous values that are available in these indexes, we are simply incrementing the counter, okay, because using this particular hash algorithm for that particular video ID 001000100, that is the answer that we got it, okay, that is the hash value that we got it, and we are just utilizing them and updating those particular indices. Okay, same for AMD5, like at this particular index 1 is the value that we got it for that particular 1 2 3 4, and SSA2 for this particular algorithm, let's suppose here is the value that got updated, here it got updated, here it got updated, like this. Okay, using this last algorithm also, here and here it got updated. Okay, so this particular video ID hash values, whatever we got it, we generally updated them across all these indices. Okay, that is what we have done so far. Okay, now let us suppose again another video came into account, and for that whatever these hash functions using them, answers that we are getting it, those indices are something what we are updating it. So for another video, like let us suppose there is the ID 2 3 4 5, and using this particular algorithm, the output that we got it, the hash value that we got is like at this particular index, we got the value. Okay, so the answer is like 001010000, something like that. So here whatever previous value that we have, we are simply updating it, and at this particular index also we got the value as 1 for that video ID. So here also again we are incrementing the value whatever the previous value that was available in that at that particular index. Okay, for MD1, like here it got updated. Okay, so that's how things were going on for each different videos. Now how can we get the approximated results for any particular video, right? That is the question. So for any particular video ID, when we try to get the result, we know that for this SHA256, what is the hash value of that video, right? So we go and check what are the values that are available in those indices. So for first video ID, it was like at this particular index, and this index we got the incremented value, right? So we simply go there and check what is the minimum value that is available, right? Because there are chances that so many videos we are getting it, and constantly they are updating the index value by incrementing the counter, right? Now any particular video that is there, right, there are high chances that in this particular table, wherever the hash values that we got it, right, those indexes may not affected with any other videos that we got it. So whatever minimum value that is available, because at the end any video ID that we are having, that may get the same index as hash value from calculating these using these hash functions, but there are less chances that the same video is getting updated those hash values across all the tables, right? So the collision will be there at any point in time. So that's why we are calling it as an approximation algorithm. But whatever minimum value that we are getting it for those video IDs among all these hash functions, that is something what we have to take out. And the approximated value that we are getting it among all these minimum value from this array, that is the count we are simply saying for that video. Okay, so this is how we are calculating the count, like how many views a particular video got from this algorithm. And this algorithm generally do not take much memory, but again there are collisions that may happen. So obviously the longer the width and the height, the less collision that we may see, but there is a trade-off, obviously, like if we try to increase the width and height, the memory consumption will be there. So that is something what we have to take care of, and simply we cannot rely on this count sketch algorithm. Along with this, we have to use min heap. Inside the min heap, like 1,000 such videos, whatever we are getting it, right, we simply update these tables. Okay, that is the first thing that we do it, and then simply get what is the count for that particular video. Now the moment we get the count, we will simply see in the min heap whether this particular video can fit, right? Because in min heap, obviously the data is already in sorted order. So along with this count min sketch, we will use min heap to update the top trending video that is available. Whatever videos highest count that is there in the min heap, it will reside at the bottom, right? So obviously that is how we can trace continuously. And the moment 1 hour completes, right, like this results that we got it inside the min heap, that result is something we can directly put it into the cache or in DB, something like that. We can again follow the same path, or simply put it into the cache, as in if we want to reduce this database connection as well. Okay, so that's how we calculate them. And how we can put these count min sketches, like for each hour basis, there will be count min sketch algorithms that are running. Okay, and for a daily basis, again we will keep on tracing different count min sketch. Okay, again for weekly and monthly also, there will be different count min sketch algorithms that are keep on running, and they are collecting the results and updating it with respect to the min heap that we are tracing for them. Okay, that's how we can integrate the count min sketch inside right over here, and then we can give approximated results back to the users. Simple. Again, let's talk about the flow. So the first thing is like from different regions, the views are something what we are getting it into the load balancer, and from the load balancer we are simply putting those views into this views service, something like that. And then these service are the producers, they are producing the events and putting it into the Kafka. From the Kafka we are polling all the results, and inside consumer we are aggregating those results. If these consumers may fail sometimes, right, those are the possibilities. So again, from the consumers, like we can have replicated data, or even we can put the counts or whatever results that we are getting it into the S3. From here we are pushing the data into the database. From database continuously for each hour the cron job pulls the data and push it into the cache, and from cache the results, whatever training videos requests that are coming from the clients, that is what we are returning it back to the users. Okay, this is how the flow basically works.